Welcome back, daily leet coders, daily LeetCode, daily LeetCode, day 52. We're back once again. We're back once again. We just got off. We just finished talks with Elon and Joe Byron. We're making sure that we're allocating. I think about 33% of the U.S.'s available networking resources, and we're rediverting it to the HCC, which is the hyperbolic coding chamber. So we found a way to get about 100 million more spots. So feel free to join. It's very important. Also, I missed a comment in the last video by the legendary Thomas Wong. It's part of the game, brother. Gotta AC those mediums like slicing butters. Actually, facts, brother. And so he mentioned 1763 longest nice substring. Don't cheat with brute force. So I think we could try this problem, but I'm pretty sure we're gonna get cooked. We're gonna get baked. Give me 1 second. So I just pulled it up. Oh, okay, it's an easy. Okay, so I thought it might be something crazy. I thought it might be like a medium, but honestly, sometimes the easiums are harder than the hards. So we might get baked by this. So I want to do it. Don't you with brute force, try for O of n. So O of n might be okay. It's one of those those easies where the start, right? It's easy to get a simple solution, right? But then getting to linear time is where the hard kicks in. So I will try my best, Captain. So I don't think we're going to do this problem today. Actually, yeah, I don't think we're going to do this problem today since we have to. There's still O1 matrix, right? Actually, my brain is kind of fried, so I don't know if we're going to try O1 matrix again. The optimal solution. I think the optimal solution is dynamic programming, and if that's the case, then oof, right? It's definitely gonna be new. So maybe we'll just actually do longest nice substring today, like Thomas mentions, and then see how we're feeling. But make sure to join the hyperbolic coding chamber. This is a hyperbolic time chamber to 10x, 500x your current skill levels. So you're gonna want to make sure you join. There are hundreds, thousands of people joining, and since we just got about 33% of the U.S.'s networking resources allocated for the HCC, it's gonna fill up pretty fast again. So just make sure you join. And yeah, we're just gonna jump in. We're gonna do a shorter session today since my brain is a little fried. So you have a string S is nice if for every letter of the alphabet that S contains, string is nice if for every letter of the alphabet that S contains, it appears both in uppercase and lowercase. For example, A, B, capital A, B, B is nice because A and A appear, B and B appear. However, A, B, A is not because B appear. It's not because B appears, but capital B does not appear. Interesting. So we have Yaze, and I think this should be false, right? Wait, oh wait, no. For every letter of the alphabet that S contains, it appears both in uppercase and lowercase. Given a string S, return the longest interesting. The longest substring of S that is nice. If there are multiple, return the substring of the earliest occurrence. If there are none, return an empty string. Interesting. The longest occurrence, or the substring. Return the longest substring of S that is nice. We have to return the longest substring of S that is nice. We have BB, BB. BB is a nice string because both BB and B appear. Right, the longest substring, we actually have to return the actual string. It's going to be A, lowercase, large a, lowercase a. There are no nice substrings. This is interesting. So I'm thinking there is no follow-up to this. However, ABA is not because B appears, but B does not. So just to generate some solutions, it seems like I think our best conceivable runtime for this, we know from Thomas, is linear time. So linear time is possible, but finding the longest substring means we can't rearrange the strings. The longest substring would be, wait, is nice because A/A is the only letter of the alphabet in S. Wait. A and A appear, and B and B and B and B appear. However, ABA is not because B appears, but B does not. So I'm not actually understanding that is A/A is the only letter of the alphabet in S. Well, Z and Y are also in the alphabet, and both A and A appear. A is the longest nice substring. So I think maybe we could do a sliding window pattern solution here. If imagine we have a window, right? We have Y, right? We know that this is not a nice substring, right? And then we have A. We know this is still not a nice substring, right? Maybe we have a map of our window, right? We'll know that it's not a nice string, right? We'll add Z. We'll add Z, right? Well, we still won't be a nice substring. And we'll add A, and A. How is this an easy? Longest nice substring. Maybe I'm overcomplicating it with my potential ideas. It appears both in uppercase and lowercase. Maybe I should have tried this with a fresh brain. Did like 6 hours, 7 hours. For example, A, B, B is nice because A and A appear, and B appear. However, ABA is not because B appears, but B does not. Sliding window definitely doesn't make sense here. Particularly because it's hard to know when our window should grow and should shrink. Maybe we could create a sliding window anyway. The time complexity would be pretty crazy. But even then, if we have a window, right? I think what we could do is we could start, right? We'll start with a string. We'll say, okay, we have a nice substring, right? Then we add another string. It's not a nice string anymore. So then we'll restart. We'll have A. We have a string. We add another one. It's not a nice string. Then we have Z. We add Z. It's not a nice string. We add A. It's still not a nice string. Then we add A. It's not a nice string. Then we add A. It's a nice string. We add another A. It's still a nice string. We have Y. It's not a nice string, so we'll restart. A is a nice string because A/A is the only letter of the alphabet. Yeah, my brain is absolutely fried. I shouldn't have tried a new problem. BB is a nice string because both B and B appear. Whole string is a substring. Maybe I'm overthinking. Well, if we go with our original answer of the next string having to make it a nice string before we start, do we miss versions where we could have A, lowercase a, and then capital A? Given string S, return the longest substring of S that is nice. If there are multiple, return the substring of the earliest occurrence. If there are none. Since they say you want to return the substring of the earliest occurrence, and we're likely going to be moving sequentially through the array. That means we could do what we said earlier. Maybe there's a way we could substring, right? S that is nice. There are multiple return the substring of the earliest occurrence. That Yaz a lowercase y however, a lowercase b capital A is not because B appears, but capital B does not. I think there's probably also a divide and conquer approach here as well. If YAZA, capital A, lowercase a, Y. Let's see if we can get a hint. Brute force. Well, we could have done brute force, right? So maybe let's see if maybe we'll find some intuition by implementing brute force. Brute force, right? We start from each string. And we could do a double for loop. We'll have Y and A. So we start at Y, right? Start at Y, and then we'll pretty much iterate until the end, right? And build a string. We're gonna see the longest substring that exists at this index, and then we go to the next one. And so I think what you could do that, right? In that sense, we would be generating all nice strings. Set this equal to an array to start, and we would have a semicolon. We have all nice strings. We want to do a double for loop, right? We'll start at Y, and then for Y, we'll see how far we can go to see if a string is. Wait a second. No, that approach wouldn't work. So think of an approach where we could if we wanted to return the longest possible nice string, without actually returning the actual string, I think we could do that. But it would just be like subsequences, so that wouldn't actually make sense. The brute force approach, we start at Y, A, Z, and how does this generate? I guess we could, like they said, check each substring to see if it is nice. So we basically have to have an is_nice function. To have a function that is nice, right? We're going to do for let I is equal to 0, I is less than s dot length. I plus plus, and we're failing Thomas here because he wanted a non-linear solution, but we'll get there. I could change to J, right? J plus plus, and then we'll create a string. We'll say const string will be equal to an empty string to start, and then we'll add a character to the string. No, we'll check if it's nice first. So we'll say is nice string, and if it is, then we want to do all nice strings dot push string, right? And then afterwards we'll do string plus equal s sub j. And then for is nice, given a string, we want to be able to tell that it's nice. And I think if we're given a string like yaza, then for a particular A, capital A, lowercase, we want to know if it's nice, and we could load the values. Yeah, I think what the good point to start with this problem is, how do we tell if the string is nice? We know the string is nice if for every letter of the alphabet that S contains, it appears both in uppercase and lowercase. So I think we could do that in linear time with linear space with a set. And so we'll return a Boolean value. It'll be 2 linear iterations to the string. One to set up the set. We'll have a set of strings. Basically, these are just going to be one character. We could iterate through for const char of s. We'll do set.add char. So now we'll have every character in s in a map, right? And then we know that for every letter of the alphabet that s contains, it appears both in uppercase and lowercase. So to do that, right, we'll return false in the case where we can't find this. Actually, we'll return true, right? And then we'll iterate through the string once again. And we'll say if set.has car.to lowercase, or if set does not have car to lowercase, or set does not have car.to uppercase, right, then we will return false. So if the set doesn't have an uppercase, right, or maybe it has lowercase but doesn't have uppercase, or it has uppercase but doesn't have lowercase, we want to return false. Otherwise, we'll return true, right? Then afterwards, we'll have a list of strings, which we'll want to sort, right? And we'll say strings.sort a comma b, right? A dot length, which would be an array, is less than b dot length. And then we could return all nice strings sub 0. There's always at least one character in S, right? And if there's another thing we have to check, right? If, right, we'll say all nice strings dot length does not, if it equals 0, then we'll return empty string, otherwise we'll return the first element. And let's see if this makes sense. Forgot to use the function to lowercase, that's not a type string. To uppercase does not exist on type string. Did you mean? Oh, it's a, yeah, uppercase C. And our string is a constant. Let's change this to a let. Interesting. So we're getting nothing. So we have a string, right, called yaza a, right? We start at index 0, which is y, and start at index j, which is 0. And then at y, we'll say, is this string nice? Right? It's not. right? So we don't push it, and then we'll add y to our string. Then we add a. Is it nice? No. Then we add z. Is it nice? No. Then we add a. Is it nice? No. And pretty much it's never nice. But it should eventually have some output, right? When we get to this version right here, I wonder if is nice might not be returning the proper output. Or we can also test, right? So just for this case, we'll test that the string AAA is nice, and we'll print that to start. Just to make sure that is nice works. So is nice does work. Let's print string to see what's going on here. Oh, I see what's happening. We're starting at, right, so we want to say j is equal to I to start. Right, so we should be getting some value. We're actually getting AAA as a potential value. So we check if AAA is a nice string. If it is, we push it, and then we add a character, and we print it. Yeah, this is a strange one. I'm not understanding. We get that it is actually, our output is AA. Okay, so our output is AA instead of AAA. That is strange. Yeah, I'm not understanding. Let me print is nice up here, and I think we might have an ordering issue. No, we should have a here. We're adding the string. Yeah, I'm. Oh, is there? No, there's not an extra space. We're printing console.log string. We're saying is AAA a nice string? Oh, an empty string is also. I see. I think we can tell actually if we print, right? I think if we print all nice strings, we'll see that empty string, I think, is in there. Right, so there's actually a couple of empty strings in there. That's actually interesting. I wonder, oh, I guess because we're starting, yeah, we check if the first string I see. So I think what we want to do is you can delete this line, and we'll basically say, right, if s.length equals 0, we'll return false, right? It's not a nice string. That way our data won't be skewed towards empty values. Oh, and then we wanted the longest substring. So if we wanted the longest substring, I'm also, oh yeah, this is after. We want the longest substring, right? So if that's the case, we can do b minus a dot length and return the first element, which should be the smallest, I mean the largest. And I remove console.log. some reason we're returning an empty string here. Which is strange. We shouldn't have any more empty strings. So for I is equal to 0, right, we're going to start with the string. We're going to start with B, right? We check if the empty string is nice. It's not, so we add a capital B. We check if capital B is nice, right? We set J equal to I, so it would be 0, right? We check if the string is nice. Empty string, it's not, so we add a character. So I'm thinking now we actually want this up here. This is a very slow solution, and there's actually no solution given up. So I think this would be this would actually be, we have a double for loop, so we have n squared time, but our solution to check if something is nice is at worst case, we're iterating over the entire string. So I would actually say this is n cubed time in the worst case. So maybe there's a linear times solution. Linear time solution. What if we remove the pairs? So if we had this string here, AAY, we remove these two Y's, right? We remove A and A, right? There would be 3 strings left. This would be what we have remaining. Doesn't seem like a viable option. What if we only remove pairs that have a uppercase and a matching pair? Have Y here, Y here, and with A and A. If that's the case, then longest string. So this is actually not the string we want. We want A, capital A, lowercase a. So if we had A, how could we make this? B. We have capital B, lowercase. I mean, this one makes sense, right? I think I know what we could do. So what if we have a sliding window, we'll have YAZ, right? And then as we iterate through, what we'll do is we'll make certain, right, on each iteration, we should be able to tell in constant time whether or not our string is, well, it wouldn't be constant time. This would be, I think in worst case, it would be n squared time. So it'd be an improvement. We'd have Y, right? We check if it is a nice string. Then we'd have YA, right? And it's not a nice string. No, that wouldn't work either because we want a greedy version. want a linear time solution. Linear time is interesting. What if we did add, addition, and subtraction, right? No, that doesn't quite make sense. Okay, well, if we know that the nicest string has, let's read the problem. For every letter of the alphabet that S contains, it appears both in uppercase and lowercase. Given a string S, return the longest substring of S that is nice. Longest substring is S that is nice. If there are multiple, return the substring of the earliest occurrence. None return an empty string. That one is, yeah, the linear time here is very, very difficult. This would be like, our current version is n cubed, related topics, hash table, divide and, I knew there was a divide and conquer solution to this. I knew there was a divide and conquer. There's also a bit manipulation. I knew there's something there with that. So I know you can add, I think we could add, right? If we add, another way we can check if a substring one way we can check if a substring is nice, we could also use, this version uses 2 for loops over S. Another version, right, we could iterate through the string, right, we have Y, right, and we'll check, we could have a map, right, of character to occurrences, and basically we'd want pretty much, this one we're definitely gonna have to get back into the lab on how to make sense of linear time solution here, but there's been, I did like 6 hours today, then 30 minutes on recording. My brain is just fried, so